Hello everyone. Today's lesson is on 8.4, the law of the logarithms. So first of all, let me just introduce you with the three basic law. And this law of the logarithm is closely related to the exponential law that we know from before. Okay. So the first one is the product law. So the product law of the log, when we have a log of the base a, x times the y, okay, so both this x times the y inside of this log, then you can break this into a log with the base a, x, plus log of the base a, y, okay? Or the other way around, when you see two terms with the same base in log form, that means adding, that means that you can put the x and the y as a product, okay? So this is the product law. And the next one is the quotient's law. The quotient's law is when you have a log with the base a of x divided by a y. So this is a fractions, okay, inside of the log. Then you can break these fractions into a log ax minus the log ay, okay? So both log terms with the same base a, you just take the numerator minus the denominator, okay? And the last one here is the power law of the logs. So this is one of the most useful law that we do use it quite a lot, okay? So when you have the log a of a term x to the power of r, so when you have a term with the exponents inside the log, that exponents r can bring it outside as a multiplier. So the exponents r becomes r times the log ax, okay? Or when you see a multiplier outside of the log terms, then this r can put it back in as an exponents of the inside term, okay? So you will be seeing example that related to those laws, but there's also one more thing when it's solving for the exponents x, using the log methods, okay, such as when you have a b to the x equal to a, to solve for that exponents x. Sometimes when the base of the both sides cannot be turned into the same base, then this is another formula or another technique that we use using the log methods with the base 10, so we can calculate the x value for the exponents by using that method, which I'm going to show you later as well, okay? Now let's look at your worksheets on the 8.4, or example number 1a, when you have a log brackets 2 times 3. So in this questions here, when you don't see anything here beside the log, that means this is the base of 10, okay? So you can also break this into two terms with the base of 10 as a log 2 plus a log 3. And you can certainly calculate that by using your calculator, okay? But this is the exact form. And then when you use your calculator to get the log 2 plus the log 3, and then you will be getting the approximate form, okay? The second questions will be a log m 30 divided by 7. Okay, so this question has a base of m. Okay, so when you break this into the quotient's law, you have to make sure that you have the log of the m 30 and minus a log with the base m of a 7. Okay? So again, if you know what the base is, then you can calculate that term using your calculator. Example number 2. So when I have to write this as a single logarithm, meaning that I'm going to combine this using the product law. So since they're both with the same base 2, okay, so you can write the log 2, but you need to multiply the 5 with the 6 because this is adding. Okay, so your final answer should look like log 2 30. Okay, so of course everything has to be fully simplified, so you cannot just leave it like that. And again, this is going to be your exact form. And if you want to get into the approximate form, you can use your, oh, this one you cannot use a calculator because this is with the base 2, okay? Unlike the first one here, when this is the base 10, then you can use the calculator to get your approximate answer. The next one is the B, when you have a 3 log 2 minus a half log 4. So this is when you have a multiplier outside of the log. So this is when we're going to use both the power law and also the quotient law at the same time. So this one here, I'm going to first, using the power law, to turn this into a log 2 to the power of 3. And this one has a base of 10 because you don't see any little number there beside the log, okay? And then minus, you have a log 4 to the power of a half, okay? So I'm going to bring the multiplier back to the inside of the log as in exponents, okay? So now I have log base is going to be 10, but this one 2 to the power of 3 will give me 8. And then because this is a subtraction, so then this becomes a fractions. And 4 to the power of a half is the same as the square root of 4, so that will give me 2. Okay, so finally this one will be log 4 with the base 10. So again, if you want to get yourself a approximate answer, you can do that with your calculator. Okay, but usually we want the exact form, the exact answer, so you can just leave it like that. Now, the last one, 2C, is when you have a long questions like this. Okay, so be extra careful when you have like a double minus here and you have a plus. But first of all, let's use the power law to make sure that you have everything in one term. So I have log B with the m to the power of 2 here. Nothing goes in here, but a minus here. I'm going to put in a bracket because there's 2 minus, okay, in order to be less confusing of whether you're going to multiply or divide. I'm going to have this, okay, log B, I have the q to the power of 1/3. Okay, so this will make it much easier to look at it when you do your final step. You're going to have everything under the log with the base b. Okay, all of this term has a base b, so that means I can combine them. So m squared and an n, that means you're going to multiply m squared with the n. But a minus means divisions. But what are you going to divide? Well, it's the product between a p times the q of 1/3. Okay, so this questions, it's much easier if you can put a bracket here when there is 2 minus. Okay, so you don't want to do a fractions of another fractions, right? So this is basically what your final answer is going to be. Okay, and another practice on example number 3 is when you have everything here and you're going to bring it back. You can expand it using the power law or the quotients law, since this is all in base b. Okay, so this one basically is same as a log b, a square root of m over 5, m to the power of 5. That means you have m to the exponents of 5, but then you have a bracket of a 1/2 because the square roots means it's a half. Okay, and because this is a fraction, so that means this is subtractions. A subtractions between what? Well, you can put in a bracket here for you to see it, but then you will have the n. You're going to have a log b of n to the power of 3 adding a log b p to the power of 4, okay? And then you can remove the brackets later on. So you have, well, because this one has an exponent, so I'm going to bring the exponent's half outside. So you're going to have this with the m. So this one will be a 5 over 2. So the multiplier is going to be a 5, because 5 times a half give you 5 over 2 as the exponents. So 5 over 2 log bm is going to be the first term. And the second terms here, you have a minus of the log bn to the power of 3. So that 3 can come outside or in front of the log bn. Okay? And so when you distribute the negative, you have another negative. But with the p to the power of 4, so you can bring the 4 in front of the log bp. Okay? So your final answer, you shouldn't have any exponents. So this is going to be the final answer here. Now let's try one more for the b. Again, this one has no base. You don't see any base numbers, so that means this is a base 10. Okay? So when this is a base 10, then you will have a log. Okay? And then you have a m times. So that means it's adding another log with the base 10, but it's an n2. And then minus another log with the base 10, but here you have a p to the power of a half, because the square root of p just means that. Okay? Now putting everything's without the exponents, you will have to use the power law. So this is going to be a 2 times the log n, and then minus a half times the log p. They're all with the base 10. Okay, so this is going to be example number 3. Now, let's look at example number 4. 4a, you have to evaluate. So this questions, we need to evaluate it. Okay, so let's bring everything down first. So first of all, you have a log with the base 5. Okay, get rid of the radical. Okay, the 4 roots. So that means you have a 125 to the power of 1/4, and then to the exponents of 9. Okay, you can collect all of this together with the base 5, but you have a q roots. Okay, but I can see that 125 can, if you recall some of the fact that we did before, 125, I can do that to the base of 5, trying to match that base. So 125 is the same as 5 to the 3. So when you have a 9 over 4, okay, quarter times the 9 give you the 9 over 4, you still have another power of 3 here. Okay, so that means I will have a log 5 with the base 5 again, but here I have 27 over 4. Okay, and because of the fact that we know when you have a log 5 and 5 to the exponents of 27 over 4, so that means this question is going to be equal to 27 over 4. Okay, so if you have forgotten how do we get into the 27 over 4, then you have to look back to 8.3, one of those facts that we talk about. Okay, Now, for the b, when you have a log of a cube root of a 0.01, again, I want to remind everyone, so this one has no base, that means the base is 10. But any kind of a radical, you have to convert this back into the exponential form. So the cube root is the same as with the exponents of 1/3. Okay? And you know that because the base is 10, so in order to get the base of 10 to turn into a 0.01, so that means this is a 10 to the negative 2. Okay? 1 over 100 will give you the 0.01, and with the 1/3 outside, so this question's here, I will have a log 10 with the 10, but I get a negative 2 over 3. So the final answer here will be a negative 2 over 3. Okay, so this is because for the same reason, when you get the base is the same as the number right beside, and then whatever the exponents is going to be your answer. Okay, question C, log 4, 8 to the 3. Okay, so now the problem is we're going to have hard time turning the 8 into the base of 4. Okay, so before I can do what I did with the previous two questions, I need to find out what is the how can I turn the 8 into the base of 4. So so how can I change the 8, okay, in terms of the base of 4? So let me just set something like this here, so you know that because I want to have another line that this has to be 4. Okay, so how can I turn this 8 into the base of 4? Okay, so now I know that from here, I know that this is going to be equal to this. Okay, so remember that we're trying to solve for the x, but so 8 is the same as, the only way that I can turn 8 into 4 is to have the base of 2. Okay, so this will be a 2 to the 2, and so that 3 must be equal to 2x. Therefore, solving for x is equal to 3 over 2. Okay, so keep in mind, so that means if I want to turn this 8 into the base of 4, so that means this 4 must have the exponents of 3 over 2. Okay, but then since I have the exponents of 3, okay, for this 8, so it's very important that you keep that as well. Okay, so now I have a log 4, log 4, and the exponents is 9 over 2. So therefore, the final answer has to be equal to 9 over 2. Okay, so this is one of the technique how we can look at how we're going to turn some of the number with the same base. If they do actually have something in common, like you can turn them into the common base. Okay, and now quickly let's look at D. When you have a log 24 plus log 4, so according to the law, we can combine this into a 25 times the 4 with the base 10, because you don't see anything here. Okay, so I ended up with the log of 100, and log of 100 is the same as a 10 to the 2. So because with the base 10, so that therefore the answer is going to be equal to 2. Okay, and the next one, log 3 135 minus a log 3 5. Okay, And we can combine this according to the law as a log 3 of a 135 divided by 5, and that is equal to 27. And because I know that 27 can go into the base of 3 as a 3 to the 3. Okay, so that therefore the final answer is going to be equal to 3 for this one. Okay, and the last one, F, when you have a combinations of a minus and a plus, so you can certainly put everything, okay, with the base of 6, you have a 45, okay, and you divide it by 5, but then you multiply this, then after that you according to BATMAS, and then you're going to multiply it by 4. Okay, so so everything here, when you simplify everything, you have the log 6. Okay, 45 divided by 5 is 9. 9 times the 4 is 36. Okay, and then you know that 36 can go into the same as the base 6 with the 2. So finally your answer is going to be equal to 2. Okay, so that will be example number 4.